Hello. In this hypothesis testing by means series, I will take one by one problem. One problem I have already solved in my previous lecture. Now, in this, I want to pick up the same kind of problem, but with the condition that instead of applying Z distribution, we will apply T distribution. The reason is that the source variance is not given. Rather, the variance of the sample we are able to calculate out of the given number of bulbs life. So read the problem. In this problem, what we see here is an electric firm manufactures light bulbs that have a lifetime that is approximately normally distributed with the mean 800 hours. But the standard deviation is not given. For the source. For the source, standard deviation is not known, unknown. For unknown source variance, and what we have to test is the hypothesis, null hypothesis, mu as 800 hours against the alternate hypothesis for the random sample of 20 bulbs having an average life of 788 hours with a standard deviation of 40 hours. But before solving, we should know what are the steps involved in this problem. Null hypothesis H0 is mu is 800 hours, and alternate hypothesis is mu is not equal to 800 hours. So again, two-tail hypothesis testing, but because sigma is unknown, we will apply T distribution instead of Z distribution. Therefore, we are going to calculate the value of the T. Sigma is unknown. So in this case, degree of freedom will have an important role. This we call degrees of freedom. With respect to that, the value of T we can see from the table, or value of P we can pick up from the table with respect to degrees of freedom. For alternate hypothesis, we have to apply the criteria, which is the third one, this one. So these two are not applicable in this case. H0 given as mu is 800 hours and H1 mu is not 800 hours. So we are applying T distribution. So T is x bar minus mu upon s upon square root of n. That is in this case 788 minus 800 divided by s is 40 upon square root of 20. So that value will come about minus 1.34 approximately. Suppose this is the distribution with the mean as 800 hours. Variance is not known. Transform into T distribution. When we transform into T distribution, it will remain the same. But this distribution depends upon degrees of freedom. This is with respect to certain degrees of freedom. In our case, it is 20 minus 1, so 19 is a degree of freedom. Because of two-tail hypothesis testing, we can assume alpha as 0.05. If we assume alpha 0.05, for critical zone, we have to divide on both the sides. So both values will be alpha by 2. So this area under the curve and this area under the curve will be equal to alpha by 2, that is 0.025. So this is T distribution having mean as 0. So now this point will be called minus T alpha by 2 and this point will be called T alpha by 2. So in decision criteria, there are two ways. One is based on T value and the other is based on p-value. So for p-value, we have to see p from the table of t distribution. So t calculated is minus 1.34. With respect to that, we have to find out the p-value from the table of t distribution. Let's see what is the t-value and what is the value of t alpha by 2 with respect to 0.025. In this t distribution, t alpha is corresponding to this particular point, where t alpha suffix is representing the area under the curve. So now, in this case, for alpha 0.025 and nu as 19, for alpha 0.025 and nu as 19, the value of t is 2.093, and for the value of t as t alpha by 2 at t 0.025 is 2.093. Now for t minus 1.34, what is the value of p? If we suppose it is p, because it is a symmetrical distribution, both sides the value will be minus t alpha. So that way, what is the p value is for 1.34. If we see 1.34 lies some 1.341 is over here, but this is for 15, so it is not applicable. We have to see for degrees of freedom of 19. So 1.34 will be somewhere between these 2 points. So it will be approximately 1.3281. So p will be slightly less than 0.10. So it will be about 0.09 approximately. So if it is this one, p value as approximately 0.09 and t alpha by 2 as 2.093. So in this case, p is far more than alpha by 2. In this case, t alpha by 2 is minus t alpha by 2 will be minus 2.093, and this will be plus 2.093. So t calculated will fall somewhere about this particular point. So this will be your p value. So this will be t calculated, and accordingly this will be p value. So decision criteria will be t is more than minus t alpha by 2 and less than t alpha by 2. So H0 do not reject. Here p is more, so H0 do not reject. So in this case, the final decision is claim of the company is correct. So in this way, we see that hypothesis is not rejected because this sample size was small and the mean value shows that it is of the same properties as of the source. So variability is high and variability is supposed to be the same of the source. So this is how we can perform hypothesis testing for single sample and unknown variance of the source. Thank you very much. We will discuss the other types of hypothesis testing by means in the next lecture.